Hello everyone. In this video, I'm going to go over how to test for heteroscedasticity using both the Breusch-Pagan test and the White test. If you haven't done so already, I highly recommend that you watch my previous video on calculating the robust standard errors when we have heteroscedasticity. The two videos are meant to work together, as in this video, we're going to test for heteroscedasticity, and if we discover that there is heteroscedasticity, then we're going to have to construct those robust standard errors and use them in place of the OLS standard errors that we've been used to up to this point. I'm going to continue with the simple Mincer equation estimation from the last video. I'll regress the log of wage on the years of education and years of experience. Let's start with the Breusch-Pagan test. The idea behind this test is that we regress the squared residuals from the original model on all of the explanatory variables and test for the overall significance of that second regression. If we find that there is joint significance there, then we conclude that the explanatory variables have an effect on the variance of the error term, and therefore there is heteroscedasticity. So the first thing we're going to need to do is generate those squared residuals. So I'll start by predicting the residuals, which I will call E. Now, if you're following on from the last video, then you probably have already done this. Next, I need to generate the square of the residuals, which I will call E2 equals E squared. Now we need to regress the squared residuals on education and experience. To complete the test, we need to look at the F statistic, which is 4.9, and then the p-value, which is 0.0078. Since this is just below 1%, this looks like a strong rejection of the null that there is not joint significance here, which means that we conclude that there is heteroscedasticity in our model. I'll move on now to the White test. In the White test, we have two different ways of specifying the test. I will start with the simpler of the two. For this test, we need to regress the squared residual on y hat and y hat squared. So I'm going to need to generate y hat before I can do this. We're going to have to go back and run the original regression again, because the predict command is directly tied to the last regression that we ran. So we need to go back and run this one again, and now predict y hat, and you can name this whatever you want, xb. I'll now generate y hat squared, which I will call y hat 2 equals y hat squared. Next, we regress the squared residuals on both y hat and y hat squared. And then we'll look at the F statistic, which is 3.91, and the corresponding p-value, which is about 2%. So this is not quite as strong a rejection as in the Breusch-Pagan test, but this is a relatively low p-value nonetheless. We can reject with over 95% confidence here. Again, this is pretty good evidence that we have heteroscedasticity in this model. The last thing that I will do is run the original version of the White test. What we just did was what I've been calling the alternative or hacked version of the test. Now, the original version of the White test involves regressing the squared residual not just on education and experience like the Breusch-Pagan test, but also the squares of those two variables, as well as any cross products. When we only have two variables, there's only one cross product, in this case, education times experience. But when we have a larger number of variables, you can see how the number of variables in the original version of the White test will start to explode, because we need to have a cross product term for every pair of variables in the model. That means with just 3 variables, that's already 3 cross-product terms, and it will only get more from there. But with only 2 variables, this version of the White test is fairly simple to do. I'll need to generate squared terms, so I'll generate education2 equals educ squared. I'll do the same thing for experience. And finally, we need that cross-product term, which I will call edexp equals education times experience. I'm ready to run the regression, which is squared residuals, E2, on education, experience, education squared, experience squared, and the cross product, which is edexp. We'll take a look at the F statistic again to check for joint significance and the corresponding p-value. Again, we have a very low one, less than 1%. So this version of the White test gives us very strong evidence for heteroscedasticity in the model. So you can see that all 3 of these tests gave us a different p-value. But overall, they all pointed us towards the presence of heteroscedasticity. What that will mean is that using the OLS, standard errors will be highest estimates of the actual variance of the coefficient estimates, so we'll have to use the robust standard errors. If you have any questions about testing for heteroscedasticity, be sure to let me know. Thanks for watching.